Hi, check out this extra video on ratios. Today I'm going to be reteaching 3 topics from the most commonly made mistakes from students' work yesterday on ratios. So here were the 3 mistakes students made most and how we can correct those. First, order matters in a ratio. This is all about the translation from words to math when we create a ratio. We've seen this example many times, circles to triangles. Well, there are 4 circles and 3 triangles. So when we made the ratio of circles to triangles, the ratio was 4 to 3. When we made it from triangles to circles, it was 3 to 4. The ratio 3 to 4 is not the same as the ratio 4 to 3. Order matters. It's not interchangeable. The order should show the same order as the words or images in the problem. The order matters when you simplify too. 4 to 8 is not the same as 2 to 1. 4 to 8 is the same as 1 to 2. The order can be tricky. In the problem that you see on the top of your screen, it asks you to compare the long sleeve shirts to the short sleeve shirts. The long sleeve number must go first. Thus, the answer is 4 to 5, not 5 to 4. Which number should go first in this ratio? Should it be 3 or 2? Should it be the binoculars or the cell phones? Well, look at the pictures in the bottom row, and that's going to tell you. Here are the answers that we can see from the problems on the screen before. Order matters in a ratio. That was our first mistake. Let's go on to the second one. Ratios should be written in simplest form whenever possible. Simplifying a ratio is just like simplifying a fraction. Not all ratios can be simplified, just like not all fractions can be simplified. The first ratio on this page involves the numbers 4 and 3, 4 tomatoes and 3 onions. 4 and 3 only share 1 as a common factor, so they can't be simplified, just like the fraction 4/3 cannot be simplified. The second ratio involves the numbers 2 and 8. 2 and 8 both appear on the 2 times table. Their greatest common factor is 2, so it can be simplified by dividing both sides by 2. The order matters, so when you simplify, 2 to 8 would not be the same as 4 to 1. 2 to 8 must be simplified as 1 to 4, because 2 divided by 2 is 1, and 8 divided by 2 is 4. Let's try and simplify the ratio of dogs to cats. I will give you a little minute to count. How many dogs are there? How many cats are there? Now that you've found the numbers, can we simplify? No. There are 9 dogs and 8 cats in the picture. So we cannot simplify because 9 and 8 are not found on the same times table outside of 1. 9 and 8 do not share common factors other than 1. So we can't divide them and make them simpler. How many dogs are there in this picture? How many cats are there? Can we simplify? Well, in this picture, there are 3 dogs and 2 cats. So we cannot simplify because we can't find them on the same times table. Their greatest common factor is just 1. So that doesn't help us when we're trying to simplify. Now, let's look at this next picture. How many dogs are there and how many cats? This time we have 2 and 2. So we have to simplify this fraction to 1 to 1. Okay? In this case, we're dividing both sides by 2 because obviously the number 2 can be divided by itself. Here we see 1 cute little dog and 1 cute little cat. So the ratio is 1 to 1, and it can't be simplified further. Watch out. I want you to see that both of these pictures, even though they show different numbers of dogs and cats and different numbers of animals in total, they both show a ratio of 1 to 1. 1 dog for every 1 cat, or 1 cat for every 1 dog. Simplifying is all about finding equal groups on each side of the colon, or on each side of the 2. We have on the left 18 bottles of jam, or 3 groups of 6. On the right, we have 12 bottles of peanut butter, or 2 groups of 6. Both sides can be divided into groups of 6. So 18 to 12 can be simplified to 3 to 2, just like the improper fraction 18/12 can be simplified to the improper fraction 3/2. Ratios should always be written in simplest form whenever possible. Remember everything you learned in fractions, and this part will be easy. Let's go on to the third most common mistakes. We need to know the difference between part-part ratios and part-whole ratios. This, again, is all about those translations from words to math. When we're writing in math terms, we're usually making it much shorter, so it's important to make sure that we are precise and always communicate what we mean. So let's go back to this example we've looked at before. First, we just looked at the ratio of circles to triangles and of triangles to circles. In this drawing, part of the drawing shows triangles. Another part of the drawing shows circles. But if we look at the whole drawing together, the whole drawing is all about shapes. So when we look at the ratio of triangles to all shapes, we're zooming in to look at the triangles and zooming out to look at everything. To understand this problem, we needed to know three keywords. We needed to know triangle and circle, and then we needed to know shape. The most important thing here is that we needed to know that triangles and circles are both types of shapes. So part and part whole ratios happen when we are distinguishing categories and things inside those categories. Remember that that word to always joins the items that we're going to compare, and to translates into a colon when we put it in math terms. The first two ratios are part-part ratios because we're zooming in on each part of the drawing, just to the circles or just to the triangles each time. The last ratio on this page is a part-whole ratio because we are zooming in to look at the triangles and zooming out to look at everything. That's why we have 3 to 7. I want you to note, part-whole ratios can be a little bit tricky because you end up counting the part 2 times. Notice in the ratio 3 to 7, the 3 counts the number of triangles, and the 7 counts the number of triangles plus the number of circles. So in that way, we've actually counted the triangles on both sides of the ratio. You must know the difference between part-part and part-whole ratios. To be the most successful ratio student, make sure you know this, make sure you can simplify, and always keep your ratios in the correct order. Thanks for listening and working on correcting your mistakes. We'll keep moving forward with the growth mindset, and I'll see you next time for another video on ratios.